and welcome to the live stream. I'm going to be joined by the amazing Kathryn Ross. We're going to be taking off in 2 minutes time properly, but please make sure you answer all your questions in the questions section. And if you're watching again, thank you so much as well. We are just waiting for everybody to join. I'm just going to turn my speakers up. Can you, want to say hi?
Hi.
Excellent. Awesome. Okay, brilliant. All right. Well, we can get started. Okay, so I'm going to show the first question. And this one's for you. So why is it that light and gravitational waves travel at the same speed? Is this symptomatic of an underlying upper bound limitation in our known universe?
Awesome.
What a great way to start. Oh my God.
That's a good question. I guess it all really comes down to math. So when Einstein was developing general relativity, the one key concept was that nothing in the universe, absolutely nothing, can travel faster than the speed of light. That is the absolute speed limit of the universe. So it's around 3 × 10⁸ meters per second. So
wow.
incredibly fast. And that is the speed that light travels in a vacuum. So we can measure that, and we know that that's what it is, and it's really, really fast, but we weren't actually sure if gravitational waves would travel at the same speed. It was all theorized. The last discovery of the neutron merger basically showed that they do travel at the speed of light. We're pretty much certain that they do, because the gravitational wave detection from the actual merging was around 1.7 seconds before the detection with EM waves. So when you do the math of general relativity, you see that not gravitational waves, very different to gravity waves, do travel at the speed of light. And that's how we predicted it, and seems to be how we observed it as well.
Wow, that is phenomenal. Oh my goodness, what a great way to start. I'm getting a bit of an echo, but I'm just going to turn my speakers down. All good? Right, so before we get into any more questions, just so you know, we'll be giving away this amazing original artwork. Woo! And to enter to get your own piece, all you'll need to do is simply write either a comment or a question. And we'll pick our favorite comment or question, and then we will we'll pick from a winner, and then we'll send you the artwork. You might need to turn your speakers down a little bit, Kathryn.
Oh, sure, sorry.
All right, guys, let's get into the next question. Okay. Oh, right, this is a big one. So can you take us through your process from beginning to getting a painting idea? How do you decide how many sections you're painting? What part do you start? Do you sketch? There's a lot of questions in here. Do you sketch the question? Do you sketch out all the shapes and areas first freehand? Will we see you on the streams and live demos? I'd love to know. How do you, oh God, I lost the question. How you decide which parts into a glimpse, the way you paint would be great. Okay, I'll just take you through the basics, right? And I've obviously got a real painting behind me today. Oh, I'm joined by Dave the dog. Everyone wants to say hi to Dave. He's here. He's just gonna, I've stolen their squeaky toy so that they don't make too much noise. So, by the way, guys, can everybody hear us nice and clearly? Just write in the chat comments if you can. If there's any issues, just let us know. The first part about the painting is obviously actually just the prepping of the canvas, and that's a very big special process where it's all painted in crushed marble, and I mix it with a very special black ink to make it super, super black. And then it's sanded and processed. So once we've got the canvas, I suppose initially I just like bring together like cool ideas about the universe. Like, I'll search for a lot of images online, and I'll read a lot of scientific articles and see what inspires me. And then I just sort of sit and think about it, and then I just get a vision in my head, and I'm like, well, I know what I'm going to do. Yeah, okay. And then most of the time I paint in black and white first, and then I color tint. But not always. It really does depend on the piece. As far as how many layers, look, it really depends on how complex the painting is. Like for this one, for instance, the background was done first, and then this was done second. In fact, actually, the background was done about 4 times because I didn't like the colours. And then I had to paint the trees twice. And I don't know if you can see, I actually went to the length of painting every single leaf, which took ages, but it was all good. All right, I'm gonna go and just quickly look through some of your comments. Nicola said hi. Kathryn. Brennan says hi. Hi, Brennan. Hope you're well. Big shout out to Frank as well, and Adrian. Great to hear from you. Macbeth. This video is auto-played and scared me into space. A big shout out to Anthony. He said cute pops. They love space, or at least they just put up with it.
So adorable. I love your dogs. Just amazing.
We'll get puppy number 2. Come on, pup.
Ah, thank you. Yes.
She only just trucks for food.
Thank you, Mika.
And also a big shout out to Rhiannon. Oh, great. Good to hear from you. Also, Eric, nice to hear you. These are Rottweilers. This is Dave in the background. You can see just hiding. Oh, this is Isa. She's just come for a little cuddle. Okay. And a big shout out to Mika, who said, cool mug. It is an awesome. Is that yours?
It is mine, yeah. I mean, as a physicist, I drink a lot of coffee. When you're sitting at your desk coding all day, you need a lot of coffee to get through. So you have to have it in a fun mug. Otherwise, it just doesn't count. It just doesn't work. So.
That is amazing.
Actually,
I think you should just rep your T-shirt for a second. I've just noticed.
Oh, yeah. So for those who can't see, I'm wearing an Earth T-shirt, essentially. I'm not sure if this has gone international yet, so Australians might know, but if you're not in Australia, it might seem a little weird. So a few months ago, there was an announcement by the Australian that we have a space group like NASA in Australia, finally, yay. So essentially, the next day, I think it was very soon after, there was a group that came out called the Australian Research and Science Exploration Group, which stands for ARS. And they came out basically looking extremely legit, huge website, merchandise, Facebook, Instagram, the whole thing. It's not our space research group, but very entertaining nonetheless. And I'm all for a good nerdy shirt as well as a nerdy mug. So
I actually, for a moment there, was like, whoa, is this for real? Because you never know. Because like this is.
Yeah, it took me a while as well because it was so professionally done.
It was
you
amazing.
Just look at me like, is it though? Is it not? I don't know.
Actually, what you're talking about, I'm going to find the link and send it to everyone.
Great, please do so. It's hilarious. It's really great. And I mean, I'm always down for some science humor as well as space humor. It's all fine with me. So thank you for the compliments on the shirt, everyone.
I love the fact that we could. I mean, that is just a pure Aussie humor, and if anybody actually saw my Imager post, it's probably quite poignant. Okay.
I think the only issue with this, as I wore it to uni one day, and a lot of physicists came up basically saying, do you know that that is fake? And I had to explain that, yes, I was aware.
It doesn't matter.
Humorous. So.
Okay, here it is. I'm going to send this to everybody so you can all see. I'll pin this link.
Fabulous.
Wrong one. There we go. And this is their website. So we're not plugging for these guys, but it is hilarious. And
it is definitely
you've got a good sense of humor. It's great.
Yeah.
Okay, right. So we're going to get into it. So
not official, which is just, it's so fun.
If anybody has any science or astro related questions, please make sure you put them in. just so that we can make sure that we make full use of our amazing science communicator, Kathryn Ross. Wow, there is a lot of things here. Okay, right, so we're going to go with this next one. It makes perfect sense as still, there's a lot of talk about the vacuum of emptiness of space not being a total nothingness, but being something. And to me, it makes perfect sense, and it still really is there with the fabric, whatever it is. If anything can get there, is there something? So about these are very long questions. You might want to keep them a tiny bit shorter, guys, by the way, just so, because these are quite hard to get through. So gravitational waves, are they something that travel through the fabric of space-time, or are the ripples of the fabric itself?
Cool, yeah, so it's a bit of a tricky one because, I mean, yeah, there is the vacuum of space, which is sort of the region between stars, between galaxies, but it's not a perfect vacuum. In fact, we have what's called interstellar medium between stars, and it's it's very, very difficult to get a perfect vacuum when you have a whole lot of galaxies and stars blowing stuff everywhere. So yeah, it is a vacuum, but it's not quite a perfect vacuum. But when you talk about this fabric, that is what we call space-time, and it's very difficult to understand because it's really counterintuitive. And even as physicists, I think half the time we know what it is mathematically and we understand the maths, but when you try and physically understand it and picture it, it's too hard. So you kind of have to a little bit sometimes. Because essentially when we talk about space-time, it's because there's 3 dimensions of space and then 1 dimension of time, and that's why it's space-time. And we use that sort of understanding of our space-time thing to put into like a metric and into the maths and to understand like how it moves and how it works. And that is what moves when there's a gravitational wave. So the gravitational wave arises when you have 2 masses. At the moment, we don't have, sensitive enough equipment to have not very dense mass or not very massive objects. But previously, it was only gravitational waves until very recently when we saw neutron merger, so 2 massive stars, neutron stars, and the gravitational waves occur when these massive stars are orbiting around each other and they're slowly falling into merge. Now, as they do that, they get faster and faster and faster and faster until that point of merging. And that, as they're falling into each other, that's what causes ripples in space-time. So we don't actually see the things merging with gravitational waves. We see the sort of effect that their merge has on space-time. And you can model this, or you can do the maths as well. Again, more maths. There's a lot of maths involved in general relativity. And you can do this maths and you see how it will affect space-time. So you can see that if you were to just have like a circle in space, and as a gravitational wave would pass through it, it kind of bends like this. It's hard with my hands, but you see it bending, and that's really what we're trying to detect, and it's really exciting that we saw the neutron merger recently. So for those of you who don't know, big science discovery for the first time in all of astronomy history. This is the first event that we have seen with 2 messengers. So both gravitational waves and light, so the electromagnetic spectrum. Really excited because it's just like a whole new frontier for astronomy and observational science. It means that we're going to understand our universe so much more, and there's just so many possibilities. So a dense question and a lot in it, and I hope it kind of answered what you're hoping for.
I feel like my brain has just exploded.
Welcome to my life.
A big shout out to Lars, who just became backer number 840. Oh my goodness, we've got such a big space family. Yay for Lars, thank you so much. And by the way, guys, we've released recently some brand new rewards. And these are the mega rag prints I showed you on the last session. Sorry?
There's a little...
Yeah, make sure there's a little selfies tab, by the way, guys. Hey, Frank. Make sure you add your selfies in if you can, if you're decent, obviously. Of course. I do have a question for you, Kathryn, actually, and this is something that we've touched on previously. So everybody feels a little bit heartbroken about the loss of Pluto being a planet, but then I realized that there were lots more dwarf planets, and I wondered if you could tell me how many do we actually have?
So going from the sun, so there's Mercury, Venus, Earth, Mars. There are 4 terrestrial planets. So we're all rocky kind of planets and very close in to the sun. And then skipping the asteroid belt because no planets there, don't care. Then there's Jupiter, Saturn, Uranus, and Neptune. So that's 8 planets only. There is not Pluto. And I guess it may seem sad, but to me, I find it a really happy story, and I think it has a happy ending as well. Because Pluto, yes, planet. We actually kind of discovered it by accident. Didn't really mean to find it because it is so small, and the fact that it's so far away from the sun means that it's really dim and really hard to detect. Not to mention that its orbit around the sun is so long, it takes a really long time, that it's really hard to sort of point in a random direction and just happen to find a planet. So when we discovered Pluto, it was pretty exciting because it was entirely by accident. And so we were really excited. We had another planet. We had 9 planets. It was all very exciting. Except then we got better telescopes. We got more excited about space, and we were exploring our solar system more and more, and ended up finding many other objects similar to Pluto. So we found things further out than Pluto in what's called the Kuiper belt. So it's kind of like an asteroid belt. It's further out with Pluto, where there's icy objects and a whole other little like rocks, and then there's also really big things as well. So Pluto actually shares its orbit with all of this. All of these objects out in the Kuiper belt. Not to mention its orbit, everything that orbits like on a plane with the sun, and Pluto's orbit is like this. It doesn't really fit. So as we sort of discovered more about our solar system, it kind of became very clear that Pluto didn't seem to match all the other planets. And so instead, oh no, I froze. Yeah, I must have, sorry, I was traveling too fast, so time dilation must have gotten in the way. I hope everything got through. Let me know if you missed too much information.
There's never going to be too much information about space, but would you have another question? I think would be cool.
Oh, yeah.
And the next question is, gravity waves are the current big thing. What do you think will be the next big thing in astronomy?
That is a fabulous question. A really difficult one.
I think like dark matter.
Yeah.
I'd be like, oh, by the way, we're now calling it light matter because we know what it is.
Yeah. So it's difficult because we don't even know what it is. We know that we don't know it. Dark matter and dark energy, we know that it's there. Math suggests that it's there.
Actually, before you go into that, maybe you should explain like dark energy, dark matter, there's a few people on here, I bet that, I mean, I probably don't really know. So you tell me, I'll take it.
I mean, no one knows, that's the whole point, we have no idea. So essentially, our universe is made up of lots of things, and everything that you see, all the stars, all the galaxies, everything that we see makes up 4% of the universe.
Whoa, just like stop there, wait. Stop. So you're telling me that we've got 96%, we've got no idea.
4%, 96%, not a clue. Not a clue. So it's both dark matter and dark energy, and we can detect that it's there, and we know that it's there, and we know that we're missing 96% of the universe. But because it's dark matter and dark energy, astronomers are not creative with names. So it was dark because we couldn't see it, so we called it dark. And yeah, we can't see it, so we have no way of observing it and no way of really ever figuring out what it is currently. So hopefully that'll be a big discovery or a big technological advancement that will help us. But until then, who knows?
Wow, that's just amazing. I'm going to answer a few more questions, I think more about the painting stuff. So Daniel said, when you're starting out on a painting, what's your inspiration and how do you get started motivationally? Okay, right. So obviously I've only recently been painting. I mean, like I painted back when I was in high school, but obviously that was a while ago. Obviously my beautiful, youthful looks don't give it away. But so I've always been interested in space, and I think there was probably a time when I was about 7 or 8 when I remember sitting at my bedroom window, looking out the window, thinking like, where did all this matter and stuff come from? It's a bit of a weird thing for a 7-year-old to think about, but I used to think about it all the time. And I used to think, like, the stuff that made those bricks and those trees, like, where, why, how? And I think when I looked at this, when I looked out at like the night sky, I kind of like imagine Earth like it's like a box with a lid. And then when it goes dark, it's like the lid opens up and then you can see it's kind of out into the box. And I was thinking, you know, I was just thinking, you know, it's quite phenomenal, really, all this thing about space. But when I'm thinking about space, I'm not thinking about, you know, like what homework have I got to do when I was a kid, or, you know, I wasn't thinking about like, you know, such and such a person was very nice to me, or, you know, oh, I really want to eat some lollies. You know, I was like thinking about like really big picture things. And I think when you do look at space, you stop thinking about, oh, we've got a Dave. You stop thinking about really small and like things that aren't so important. And you start thinking about really, really important pieces. And I think that was the key thing for me, why I really started loving space. Yeah, and it's just amazing. It's so beautiful. It's sort of like, what I think about is interesting about astronomy is it like suckers you in with these pretty pictures. And then it blows your mind with these amazing facts. And you just think like how big it is. You know, like, and one of my favorite visualizations, because it's so hard to visualize the size and magnitude of space. And one of my favorite galaxies is the Sombrero Galaxy, which I painted last year, which is just gorgeous. And then the middle of it is a supermassive black hole. And it is 1 billion times the density of the sun. Oh my God. Wow. Because like the sun is massive. You think like Earth compared with, I mean, just think about your house compared to the size of Earth. The Earth is pretty big. And then you think about Earth compared with the size of the sun, and that is friggin' huge. And then you think you multiply that by like 1,000. And then you multiply that by, make it 100,000, then multiply it again, do it until it's 1 million. That's how dense it is. Whoa! And I think every time I think about these things, I just like I have like a midlife crisis every time I think about it, because I'm just like, holy! It makes me want to swear, which I'm not going to, because my mum and dad will be tuning in later. But you think about these things; they're just beyond words. It is so phenomenal, and like I can't get over it. I don't think I'll ever get over it. I'll always be asking questions about space. I'm sure you guys are about the same, you know. So but yes, okay, so on to the next question, and this one is for Kathryn. It's really confusing because we're both called Kathryn, so
yeah. Shame on us having the same name. We should have organized this better. Kathryn
with a K. And Nicola said, so it is correct to assume that detecting gravitational waves, the farther away 2 lasers, the better resolution, and the smaller the waves it's possible to detect. Thanks.
Yeah, so there's a lot to unpack, and I just want to make it clear right now, I'm by no means a gravitational wave expert. I've done sort of a bit of sly research myself, and talk to people at my university about it. But as far as I understand, it's easier to detect when you have 2 more massive objects merging, which is why it was really exciting to see the neutron star merger, except the signal was really loud and really long, so I don't even quite understand what. But essentially, yeah, we're looking for the ripples. So if we have bigger ripples, it's easier to detect. And those ripples are radially moving completely outwards, so they will get smaller as you get further away. And so, yeah, that makes them harder to detect. But also then we're going, you know, within our galaxy to outside our galaxy, and there's just so much going on, and there's a lot of different objects merging, and it's all very exciting. So, yes, further away is probably harder to detect, but again, I am no gravitational wave expert.
That is amazing.
A question here. Oh, I don't know how to put it up. Frank, I'll just quickly answer it. So yeah, I'm not a gravitational wave astronomer. I'm actually a galactic astronomer. So I'm doing my PhD in galaxies. Very exciting. I'm using the Khalifa Galaxy Survey and the Sami Galaxy Survey, and potentially, fingers crossed, Hector, if it is up and running by my PhD. And essentially what that does is when it looks at a galaxy, at each point in that galaxy, it takes a spectrum, and that spectrum tells us so much information. We get the chemical composition of a galaxy, we can get the motion of stars and gas within a galaxy, so we can see if the stars are moving, you know, rotating around the galactic disk, or we can see if they're just kind of randomly moving. We can see if the gas is rotating in an opposite direction to the stars. We can see all of this sort of stuff from the spectra, and we can see that because we get that information all over the galaxy, so we can compare how the stars are moving in different regions of the galaxy. So I'm going to be looking at how stars move within galaxies to try and understand the merger history. So as galaxies merge themselves, trying to understand which galaxies have merged and which ones haven't, and get that sort of history of the galaxies. So that's my PhD in a nutshell. Yes.
Wow. If anyone else is jealous, you can just say yes in the chat box, because that is so damn cool. Oh my God.
Oh, thank you. I am so sorry my picture is still frozen, by the way. I'm not quite sure what's going on. I've done tests, but everything seems fine on my end, so I don't know how to fix it. I'm so sorry.
What's this? Oh, it's fine. It's actually playing for me. I think, oh, hi, Dave.
There's a dog.
We're obviously going to have on and off internet connection issues because we're in Australia, and Australia has arse internet, but not the good kind of arse. Okay. Oh, I know, isn't it amazing? Okay, so a next question, which is from Alexander. If you could change one universal constant, which one would you change and to what? Can I have a go first on this one? I really love the concept of the multiverse theory, that there are lots and lots of different parallel universes, and they each have different constants in them already. And obviously we have two major ones that really hold the universe together: the Higgs field, which pulls everything apart, and the gravitational field, which pulls everything together. And obviously, you could probably correct me, Kathryn, if I get this wrong, but there are some fields where the gravitational is so strong where it just collapses the whole. I mean, this is obviously theoretical physics now, but they say that there's universes which their gravitational is so strong compared with the Higgs field that everything collapses into a single point. And then they've got other ones where the Higgs field is too strong, and what happens there is that everything disperses and there's no forms of clumps or matter that form. So you've kind of got this Goldilocks zone in the middle where we've got a good balance of like gravitational pull and Higgs. I think if I could choose something that would be different, maybe the speed of light, but I don't know, because I think the problem is if you change anything, we'd all be dead. So.
Yeah, exactly. This is what makes me uncomfortable, because there's they did all this research and they're like, okay, if we changed even one little thing, there's sort of a graph where we have all the overlapping constants, and what happens when anything changes just the tiniest little bit, and essentially everything just falls apart. It either completely collapses or everything is spread out before anything can form, and essentially the universe really can only survive with what it's got at the moment. But then you have the statistical issue. We have a sample size of 1 that we're working with, which any statistician will tell you is definitely not good. And so there's this whole philosophical issue of, are they what they are because it's the only one that would survive, or are they what they are because it's what we see? If that makes sense. Issue of, like, if we were forming again, would they form to be this, like, these numbers again, these constants again, or would they do something else and still work? And it's only because in our universe, this is what we see, that that's the case. And it's a really difficult issue, and I have no idea how to answer it.
If I had a superpower, if I could choose one for myself, I would probably have, I quite like the idea of being able to freeze time. I think that's amazing. Get an extra 10 minutes sleep.
Not yet. Snooze the whole month.
But yeah, it's a really interesting questions. All right, I'm going to go to the next question, which is from Chris Nolan. He said, how long have you been painting? Do you have any tips for aspiring artists? Well, I've actually only really been painting for 2 years properly. I made it, basically, I will find you this amazing, if everyone knows TED, I love TED Talks, but this amazing TED Talk called Draw Your Future. And in it, basically, she, Patty, who's the lady that gives it, she talks about, I'm just going to copy the link here a second for you. So you don't have to watch this now, obviously. Keep tuning in, but save the link if you want to. This is actually not specifically to like just for drawing, but it's for anything. So the idea is that I had this goal that I wanted to do. I'll rewind like a few years. I spent a decade and a half in the video games industry. I entered I did special effects for a little while, but then I sort of, and character art, and then I moved through the ranks and ended up running big studios for years and years and years, and all I did was sit in meetings and answer emails, and I worked with an amazing team, and it was a lot of fun, but it was also very, very heavy workload, and I probably spent like between 12 and 16 hours away from home every day, 7 days a week for like 4 months. If anyone's ever had to do that, I couldn't function as a human being, because I literally went home to sleep and then I left to go back to work. It was horrible. And it kind of broke me. So like January 2016, I set a New Year's resolution I wanted to paint, and I watched that video I just popped up, but if you want to look at it again, you can, I don't know if I can, maybe I can put it in the chat box as well. And basically, so I drew a picture. In fact, I did this last time, but I drew a picture of me, really bad one, of me painting. It's terrible. That's me there. Don't have to be great all the time. But the idea is that you just work through your process. So I think the number one thing, if I would say a tip for an aspiring artist, is be okay with being really bad, because everyone is bad when they start. And this goes across the board for anything, right? Whatever you want to do, whether you want to be, if you're into you want to do astrophotography, even if you want to learn a new subject, be okay with being bad. And you can't really compare yourself when you're starting, because everyone really sucks when they start, and that's okay. Number 2 is make a lesson or learn something from every mistake, and and be really proud of the mistakes you've made, because it's taught you something really important. So every time I paint, even if I mess it up, I go, well, it's fine, because like I've learned how to prime my canvas properly, or I've learned I really shouldn't use this brush, or I've learned that these colors don't go together, and after every single, I started to write these down, and I've got a book of things that are like, you really shouldn't do this. This is, don't wipe your canvas with a cloth covered in dog hair, and like, literally, obviously. But anyway, you learn as you go through. You learn all these different things, and after a while, some things start to click. A big shout out to Cyril, who's just become backer number 842. Thank you so much for backing. I really appreciate that. Yeah, so you build up over time. I've been painting for 2 years. So I've gone from painting really bad paintings to, I would say that I'm probably a third of my way through my journey. I really need to learn a lot more, and I certainly won't consider myself amazing yet, but not. I've got like a vision of where I want to go, and it's like way better than this. But that's okay. It's okay to have a goal, but not okay to like demonize yourself if you can't get to it yet, because it's really a journey. And then the other thing is to do it every time you get an opportunity, at least once a week. I have this rule with my big brother. We call it the 5-minute rule. And it is that even if you don't want to do it, if you don't want to do anything, just do 5 minutes, and then that's okay. Because what will happen is after you do 5 minutes, suddenly you start to think, oh, this is what I've got into. I've got my paints out, I'll just carry on. Sorry, my dog's trying to break into my bedroom. Anyway, and I think that's probably the key thing. You've got to understand that the concept of motivation is a lie. Motivation doesn't exist. You become motivated once you start, so you have to start. So if the only way to get yourself to start is say, I'm just going to do 5 minutes, and if I can't do it anymore, or even just say I'm going to do one line, right? Whatever it is, I'm going to read my science thesis, and I'm just going to read one line, and that breaks you down. You're like, well, I might as well read this paragraph. Oh, I'll read the page, and then before you know it, you've like got into it, and then that's how you get your motivation. So that's the key things I would say. No worries, Chris. Right, I've done enough on that one. So okay, next one from Daniel. What is your favorite thing about / in space? A nice short question. Thinking of something that you want to paint. Oh, well, I'll let you go, Kathryn with a K, and I'll go after.
Okay, this is difficult. I think it actually changes week to week because there's so many great things in space, and it just sort of depends on what my mood is. But at the moment, I think I would have to say a thing called like transition disks, just because I have a fascination with planets, and I think every astronomer is really hopeful that we'll find life outside of the Earth and outside of our little bubble. And a transition disk is essentially a mini solar system forming while it's still in the middle of forming. So you've got like a young protostar, and it's just surrounded by gas and dust and everything, and mini protoplanets forming, and it's just a flat disk of everything swirling around. And I think it's just really cool because you can see the planets forming. Well, not really that easily at the moment, because it's essentially like having a bright light bulb in your face and then putting like this sort of filter thing that makes everything blurry and hard to see, and then trying to detect a tiny little pinhead within that. So it's very difficult to see. But transition disks, I think, are really, really cool because, yeah, it's understanding where our planet came from, how we formed, how our solar system formed, and understanding that to see how other places in the future might form and whether or not they'll be life-supporting, and I think that's just really fun.
Oh, that's beautiful. I didn't know anything about that. It's so fascinating.
Very fascinating.
So my favorite is actually is my screensaver. It's actually the Bubble Nebula.
Oh, yeah.
I just think it's the most beautiful thing. So it's probably one of the things I'm going to paint next. But it's funny because I'm obviously progressing through getting better and better at painting. But so I don't want to do it too soon. Like I want to wait until I'm like really, really good. But this is like my ideal. I want to paint it like maybe like 2 meters by 2 meters. So I want to do a huge, huge one. It's going to be phenomenal. So it's exciting. All right, okay. And by the way, guys, if you are new and joining, we will be giving away this amazing original artwork. And if you would like to enter to win this piece, all you need to do is either leave a comment or ask a question. Make sure it's a short question so that we can get through it, okay? And yeah, and then we'll pick our favorite comment or question, so either in the chat or the Q&A session. And also big shout out to everybody that has been leaving comments, selfies. And a big shout out to Frank, who's posted a picture of his dog, and we all love dogs. and also his amazing drawings. And a big shout out to Nicola as well. Alrighty, on to the questions.
I'm frozen again. Hello.
Okay, I think we'll both answer this one. If you could have any question about the universe answered in 60 seconds or less, what would you ask?
Oh God,
What
so
is dark
many
matter?
questions. Yeah, I would say dark matter. I think because there's so many possibilities about it. So it would be amazing, because if we could understand what dark matter and dark energy is, what our universe is actually made of, that could mean a whole new world for observational astronomy, could mean a whole new world for just general understanding of physics, not even just astronomy, but maybe even particle physics or quantum physics. So I would say dark matter and dark energy. Just what is it? If you can answer it, there is definitely a Nobel Prize in it for you. So hit me up with the answers, please.
That's sweet. Okay, so on to the next questions. Okay, from Adrian. What abstract or self-envisioned space painting would you like to see for real? Oh, damn! I think, sorry, that's my dog. I don't know if you can, it's because I've got Ham. She's quiet, but now she's crying. Oh dear. I would love to see the Eagle Nebula, I think. If I could see that in person. It's all just like Ham. How about you? What space feature would you like to see in person if you could see anything? Deep space object.
I think I would actually really like to see a black hole.
Not too close though.
Yeah, I mean, obviously not too close, because if you're falling into a black hole, there's a thing called spaghettification, which is exactly what it sounds like. Essentially, if you're falling into a black hole, the gravitational pull at your feet compared to your head is so dramatically different that you get stretched like spaghetti and ripped apart. So I don't want to actually be there, but I would like to see it.
It would be cool. Wasn't there a news article recently that said that they were actually using multiple observations from across the globe to actually visualize one? I don't know. I know they were using data, like the displacement data, to try and actually see one. I don't know if they actually managed to achieve that or if they're just in process now.
See a black hole?
Yeah.
Well, yeah, because at the moment we have really no idea what a black hole is, because the gravitational pull at a black hole is so strong that at one point called the event horizon, or depending on your model of a black hole, the Schwarzschild radius, at that point light can't escape, which is why it's black again.
Go and lie down.
Astronomers, we're not very creative with names.
Go and lie down.
Like a hole in space time, and it appears
lie down.
black. We can't see it. So we can't actually see them, but we can see matter falling into it, and we can infer their presence from the effect they have on stars and gas around them. But if we would actually just have a black hole by itself in the middle of nowhere and point a camera at it, we would see nothing. So
that's fascinating. And a big shout out to Simon, who's just posted a selfie. Hi Simon, I hope you're well. Okay, so we've got another question. Okay, so Rob said, what are your opinions on SpaceX and the possibility of moving to another planet? Also, Elon Musk. I think, you know what? I think that it's going to have to happen eventually. Obviously, we have to learn, of course, to look after our own planet. But there is going to be a point, and it's not going to be that far away, that we have too many people and too little space and too little resources. And the question is, you either impose very, very strong sanctions on people that they can't reproduce, or you can't have families, or maybe even a ticket system to have a child, which is a minefield of a situation to be in, or you can find a place where you can expand to. And I think, oh, you've got more dog action. And I think that eventually it's going to have to happen. You know, we're going to have to move to, I mean, it seems really unfamiliar to us at the moment, but if you think about it, just visiting the moon was really unfamiliar to us. And what I love about the scientific development, if you think about it, about 115 so years ago, which isn't that long ago, we didn't even have aeroplanes. The Wright brothers was only 115 years ago. You just think about that for a second, how far we've come, that we have now got an international space station, we've got reusable rockets, we've got drone ships, we've got all of these amazing technology, and it is just speeding up at such an amazing pace. So, you know, I don't think it's that bizarre. I mean, 115 years ago, they used to mock people. You know, the Wright brothers were mocked. They were almost sent to an insane asylum, and the priest thought that he was his father. I believe his father was either a priest or a clergyman, and said that it was the devil's work trying to fly. And just think about where we are today, and that was only 115 years ago. So I mean, wow, we've come so far, and we're going to. I mean, technology is not slowing down, and especially with AI and all these other things that are coming through as well. As far as Elon Musk, you know, he's a visionary, and I think obviously nobody is perfect, but I think he's doing his part to try and progress the human race, and especially technologically, and that's definitely admirable for sure.
I think it's also a big issue at the moment because we have science advancing so much, and science has become so technical and so advanced compared to, you know, previously, and it's just been a huge burst all of a sudden. And the last sort of burst that we had this, everyone was really excited and they were invested in science, in the Enlightenment, and everyone sort of was really excited for it. But then at this stage now, I think we have a real issue that our general population and the general public isn't that scientifically educated, and there's a huge disconnect between scientists and the general public, and a lot of people want to reap the benefits of science without the scientists actually doing their work. So there's a lot of people that don't believe in the scientists. So I mean, there's all the conspiracy theorists like the flat earthers and, you know, and everything, because the science is hard to understand, but it's difficult because we should have a more scientifically educated population, so that even if you don't understand the intricacies of things, because I by no means understand all of science, but I understand science as a concept and I understand how it works. I understand, you know, how science works, and I have faith in the institution of science and how it works and the results of science as well. And I think it's something that we really need to get all of humanity doing so that we can get to the next planet. Otherwise, it is going to be very difficult to convince people that the science that we're doing is, you know, A, worthwhile, and B, not, you know, that not as dangerous as people are thinking it is, and it's not just sort of made up, it's actually legit science. And I think that's going to be a really important thing that we're going to have to face together, of just making sure that everyone, even if they don't understand everything about science, but yeah, having a faith in how science works and understanding how science works, so that we can attract it.
Yeah, I absolutely agree, and I think really we can legislate it in government to make sure that people are educated, but it is getting more complicated. So that's why we need more science communicators like our amazing Kathryn Ross. Just doing a little plug in there for you. A big shout out to Mary Lanners, who's just commented, and also Mika. I hope you guys are well. Thank you so much for joining. And a big shout out to Hong Teng Jung Wilbur, who has just become backer number 843. Yay, well done. Thank you so much. Also, guys, just so you know, I have released 20 early bird extra large super rag sizes. And these are for the two mega rags, the XXL large. This is the biggest print that I sell. It's huge. So if you want any, they're live now. So you can just take a look if you want to change your pledge. Rob said, my 17-year-old son was struck by your artwork and forced me to back you. So I hope we will have a canvas piece soon. Thank you so much, Rob. And I'm really glad that you're part of the family and you're all getting involved. It's good. Right, okay, so on to more questions.
Yay.
Rhiannon said, even shorter, how do you feel about the feeling of awe and how it relates to space? And what do you like, dislike, and want to see in sci-fi books that explore astrophysics? For you see, I'm writing a novel which touches on these themes. Excellent questions. Do you want to have a go first?
Yeah, okay. I mean, I'm a huge fan of sci-fi. Shockingly, I know it's probably a surprise to most people. Yeah, I love sci-fi. Part of the reason I like it, though, is because it's not always necessarily scientifically accurate, which is like good and bad at times. I think it's good because it kind of motivates scientists to get there, if that makes sense. It's the concept of doing these things is really fascinating when you read them, and it sort of creates an inspiration, and it you know, plants an idea in the head. And I think that's really where like Mars came about as well. Like our obsession with Mars was probably from a lot of the sci-fi literature that, you know, people grew up with, and everyone just became fascinated with Mars. And then technology improved enough that the possibility of getting to Mars actually seemed possible. Like it was there, we could do it. So I think that, yeah, sci-fi is really important in that aspect. But in saying that, it hurts me a bit when it's extremely wrong, because you're like, that wouldn't work. That's wrong.
But sometimes, you know, they say things that are like not technically true, but then they turn out to be true. So there was an episode of Doctor Who. I don't know if anyone likes Doctor Who, and they basically said that there was going to be an ice volcano, an ice cano. And then years later, we found on the moon of Titan that there actually is an ice cano. And we were like, damn. Brilliant. So she said, and what do you dislike and want to see? Oh, so what do you want to see more in astrophysics-based sci-fi books?
Yeah, I think it's a difficult one. I mean, I guess I've always liked the sci-fi as well, because a lot of the time it's very like gender equal and representative. So I think perfect example is Star Trek. I know it's a TV series, but still, Star Trek is sort of renowned for being so representative, and it was actually definitely a huge part of actually wanting to become an astronomer and a physicist. So in particular, my personal favorite is Voyager, because the captain was Kathryn. So, you know, as a child,
yeah,
I was like, oh my goodness. So I loved it. And I think that's really important to, I think, get young children and even adults just excited by science and by astronomy. So I think what I would love to see is that sort of continued theme of a lot of representation and gender equality within, I know it's not especially space related, but I think it's really important to getting people excited to space and excited for just science and physics in general, because that's how we produce scientists, is creating that passion, sparking that interest. Yeah,
for sure.
So definitely.
I would say that my favorite sci-fi books are the Ian M. Banks, the Culture Novels series, and I really like the idea of how they and if anyone knows the names of the ships and so on, how they inject a sense of humor. Like, and they had a transport vessel which was called "But I Thought You Had Him," and they've got like a warship called "Of Course I Love You." And like these little like tidbits and the way that they play like the sense of comedy and humor with like this just like mind-blowing technology. And I think that's probably my favorite thing about scientific novels, because it just expands your mind a little bit, things that you don't think are possible. And actually going back to like sci-fi stuff, right? When Star Trek started and they had the little transponders where they talked, or the little flip. Wow, that's crazy. And then like, look at, we've got like mobile phones. You know what I mean?
I mean, I think there's like all these like reports of things that were first in Star Trek and then were developed later. And I think that like is a perfect example of that sci-fi, thinks of this crazy technology that everyone's like, there's no way. And then just like a decade later, it's, in everyone's hands.
It's amazing, isn't it?
I love that.
So on to the next question from Chris Nolan, who said, how and when did you come up with the idea of glowing galaxies? I've always wanted to do glowing stuff. Actually, this is one of the, I'll see if I can show you. I've got my, this is my phone. So I'm just gonna like put it here. Can you see that glowing?
Oh.
If I just, it's really light in here, so it's obviously not very easy to see, but if I just, yeah, it's a bit terrible, but yeah, so I've always loved it. Something about glow in the dark. I think, you know, I had a little pot of glow in the dark when I paint. I said this story before, but when I was a kid and I painted my ceiling in my, because I thought it was the most amazing. I was like, wow, this is like magic. And but anyway, more fool me, because I painted stars on my ceiling, but then when I go to bed I take my glasses off and I can't see. But yeah, I've always wanted to do it and now obviously I have, this is actually my glow in the dark pigment that I use, and it's just the most amazing stuff, you know, and I think it brings out the childish innocence in us all. But also I think what's special about looking at the stars is it's something that you do it in the dark. It's something you always look at, you know, at night, not typically speaking, and when you see the paintings with all the lights off, you get that same, like, I don't know if it's just me, but when I go out and I look at the sky at night and, you know, it's really beautiful, you go, wow, I get chills, like I get goosebumps sometimes when I look up and I see the stars. And I got the same experience when, you know, when I'm looking at, you know, a painting of stars and it's glowing in the dark, because it gives you that sense of like, it's kind of like you're like going into the unknown, and it's like you're discovering and adventuring, and it's like, oh, I love it. So
there's definitely such a nostalgia with it as well, because of, yeah, I think as everyone's saying in the comments, when you have the glow in the dark stars, I still have them in my room and I love it, and it reminds you of them. It's great.
So Daniel said, what technical advancements do you want most? I know.
I guess I would have to say an advancement, so that it's not space related though. But the good thing about science is generally when you have any advancement in technology, it generally helps all of science, and it can be used in areas that you don't really expect it to be useful at all. So I would just say a development of alternative fuels, something that's not going to damage our planet, because that would also then really help us in getting to other planets and maybe even surviving on that planet. Fingers crossed, you would hope so. So yeah,
dark
alternative
matter warp generator.
Pardon?
A dark matter warp generator. It just,
yeah, I mean, if someone would just tell me what dark matter is, maybe we could do that.
We can build an engine out of it. It'd be amazing. I like that. Yeah, I think that if I could have a technological advancement, it would be a teleporter. I would just teleport myself into a bakery and eat all the cakes. No, but imagine, like, to be honest, most of it's because, like, you know, you go out and it's late at night and I want to get home, and I would much rather just teleport home. But I think there would be a lot of very, very useful things to having a teleporter.
Yeah, definitely. That could be used in so many different situations.
Okay, John said, where do you go to find a good night skies to look up to? Basically darkness, somewhere out in the middle of nowhere.
Just not in the city is a good start.
I think this reminds me of a statement that Neil deGrasse Tyson said. And he grew up in the Bronx, I think, and he said, you know, he went to the planetarium and they did the planetarium show, and that was the moment he was like, whoa. And he said, where are all these stars? Because I've seen it outside. I've counted all 9 of them. And it's funny because that's the thing. Most of us live in a place which is like highly like light polluted. You can't see out. It's like that lid is on the box. And I think that more and more people are moving to cities and it's getting more and more light polluted. So, you know, it's funny. I was speaking to a kid the other day who'd never, like, always lived in the city, and had no idea, like, didn't realize what stars were. I was like, whoa, this is like outrageous.
I think there was, I'm not sure what year it was, but there was like a total blackout in, I'm going to say Chicago. That sounds familiar. But in Chicago, and they essentially had all of these emergency phone calls because people thought there were like aliens coming to get them, or there was something wrong with the sky, and it was just genuinely people seeing the Milky Way for the first time because they've been living in Chicago for the whole time, or living in cities their whole life. They'd never actually seen it. And yeah, I think so important for people to go out as far as you can to see the stars in a rural area on a clear night, because it's honestly mesmerizing. And yeah, I think that's a lot of the reason of how I still motivate myself. Because you definitely have those days where, you know, my code isn't working, I can't do any of the maths, and I just want to throw my computer at a wall. But if you just go out, luckily my parents live not in a rural area, but at least not in the city. So just, you know, go say hi to the parents and go to the Oval up the road from them, and just lying down and staring up is
like selfish.
It's just amazing. It's such a nice feeling. And I just definitely think that it's something that everyone should do at least once. Because it does just bring everything down. The level puts everything into perspective, and it's just pretty.
I don't know if it's just me, but I find the stars very comforting. I find them quite, I think it doesn't, like, even if you're really, really upset, or if you're emotionally quite drained, or if you're excited or whatever, I just find them it's like a universal embrace. I find it really, yeah, just like really comforting. I know that sounds a bit of a strange thing. And also, I would just like to say a shout out to Davey, and also Leonardo and Adrian, who've just written in the comments. I've been reading your comments, so thank you so much. By the way, guys, we are doing a giveaway today. If you would like to win an original painting, I know I've done this a few times, but there'll be new people in here. Make sure you leave a comment or ask a question, and we will pick our favorite comment and question at the end, which is coming up really soon, and we will make sure that we will give that away. Yeah, I'll just turn down my speakers. Yeah, the echoes are pretty intense today. I will make sure that we'll use
really bad.
Jeremy said howdy from Texas, so hi guys.
Hi.
Hey.
Howdy y'all.
Right, okay, so we've only got time for a few questions. We'll just put something up. Yeah, and the next question will be from Thomas Babb, and he said, if you could go see any planet, which one would it be? You can go first.
I actually don't know if I'd go to a planet, but maybe a moon of a planet, if that is a possibility. I can't bend your question and ignoring it. But so essentially, when we look at the sort of planets in our solar system, the 4 terrestrial planets are really the only ones that are potentially where we can live. So especially Mars, Mercury, and Venus are a little bit difficult. But Mars, I mean, first of all, I would also love to go to Mars. That would be amazing. But because beyond that, we've then got all the gas and ice giants, it's not really possible to live on those. But their moons are really similar to Earth. So, or they can be. Some of them have weather, they're rocky, and they have geological formation, and I think it'd be probably good. Maybe I'd go to like Enceladus. I think it would be really fun. But yeah, I don't really know. I want to go to all of them. Can I just hop around? That'd be fun. While you answer, I might go see if I can get some headphones.
Excellent. All right. So if I could choose anywhere to visit, it would definitely be Titan. I think it's the most. It's not a planet, so it's technically a bad answer. But you know, there's lakes of. What's interesting, there's lakes of methane, and that's one of my favorite. My favorite things. So in the same way that we have water here that is gas, liquid, and solid, they have lakes of methane in the same way that we would have lakes of water. And because the gravitational pull is so much weaker than on Earth that when it snows, or even when it rains, there's like the drops sort of float down, and that's amazing.
Can you hear me if I talk on this?
I can hear you very clearly.
Great. Okay. I wasn't sure if this
Everyone's still getting an echo. It's better. Okay, great.
Good. Excellent.
Yes.
Awesome.
Okay. Right. So Europa the Moon. Davey says Europa the Moon would be my choice. It also has weather and ice, maybe water underneath the ice.
Yeah, and also potentially life. We haven't ruled that out yet. So
yes, of course, because I'm correct in believing that that's part of why Cassini was.
Yeah.
You want to talk a bit about that?
Because essentially Cassini was running out of fuel anyway. So we could have just left Cassini orbiting around Saturn, but not really having any control over it, except that would be an issue, because what if it did crash into one of the moons like Europa, where we haven't yet ruled out that there could be life? And so if we ever found life on Europa, how would we know that it wasn't caused by a microbe, or how would we know that we haven't like killed it from Cassini crashing into it or something? What if it was just really fragile, just forming, and then Cassini comes and ruins it? That would be heartbreaking. So it was kind of a better safe than sorry story that Cassini, which was really great because Cassini went to discover stuff like that and to see if life could form on there, and sort of Cassini's data meant that it had to die, which is sad, but also really good because it was such a good mission and there was so much data that came from it. So bless you, Cassini. Thank you.
Okay, I will check your question. Leonardo said, "Can you paint different wavelengths with the glow paints so show actually different in the dark?" Yeah, of course. In fact, I have done that a few times. It really depends what I'm painting, though. Because often I mix the paints, the phosphorescence actually into the paint that I'm putting on for the daytime. But yeah, I've done that a few times. Yep. Oh, another Kathryn.
Welcome, Kathryn number 3.
And she said, "Could you recommend your favorite resource for learning more about space?"
Ooh, that's a difficult one for me because I always just go down the hole to another astronomer, I guess. So Kathryn, maybe you're Kathryn with a C. Maybe you're better at answering this one than me.
Look, it depends what level you want to learn at, but I definitely think that even just the basic NASA resources are insane. They post articles, tutorials, and lectures regularly, and I definitely would check those out if you could. But also, I would. The European Space Agency has some really great material on as well, and their website is just phenomenal. So I would definitely check those out. I think also, if I remember correctly, Caltech actually post a lot of their university lectures online, and they're free to access. So definitely worth having a Google if you've got a second.
And it's also very important to make sure that where you're getting your information is obviously good. So yeah, definitely checking out the space agencies and universities is a good way to go, because space has, it sparks so much interest from everyone. It's difficult because it means that everyone then wants to post what they think about it, and it can be confusing what's actual science and what's sort of people's beliefs. So yeah, I definitely think universities and space agencies is a good way to go. It's a good point.
This actually isn't in the question section, but it's in the chat. So Frank says, "Question for you both: if you would get an hour of private time for Hubble, what would you go to see?"
Oh, that is
everything.
Tricky. Yeah, there's so much to see. How do you limit it? I guess you go first.
I was going to say, I really like the Rotten Egg Nebula. I just think it's fascinating. I'm going to post you a picture. I'm just going to Google one now. But if you want to carry on with yours.
Yeah, I think I would do another deep field view. So the Hubble Deep Space Field View is sort of as far back as we can, like a optical image is just really far back, and there's so many galaxies. And it was really the first time that we'd considered just taking a really small area and just, instead of observing, as much as we can this way, but looking literally as deep into time as we can. I think I would do another one of those, but in a different area. Yeah.
Good answer. All right, guys, it is coming to the end. So I am going to pick a name. I'm just scrolling. And it has landed on Davy. Oh my goodness. So thank you so much for tuning in. Davy, if you want to send me a message on yeah, congratulations.
Yay, congratulations.
If you want to send me a message, and I will organize the postage for you. Yay!
Yay!
Close the door too, of course. All right, guys. Thank you so
Thank you
much.
so much.
We will be doing another live stream next week, so please tune in. Big thank you to Kathryn Ross for all her amazing insights. It's been wonderful.
Thank you for having me. This has been so much fun.
It's been great. And look,
thanks for all the questions, guys. They were incredible. There's such good questions there.
Great questions.
Yeah.
And yeah, if there's anything else you want to ask me, any questions, you can just message me via Kickstarter. And thank you so much. I did just notice here one last thing. Mahmoud said, did you see my question for Kathryn? I'm just going to double check to see if I've missed something in the questions tab. Oh yes. So one last question.
All right.
Said, hey Kathryn, my little sister is really in love with the cosmos. I can't quite express it into words. She actually feels so intimidated by the point that she's so insecure not to chase a career in that subject. That is why I actually am a backer, so that she's a daily reminder that she can actually do this. I might be rambling now, but Kathryn, how would you encourage her?
That is an incredible question. Thank you so much. And to be honest, it's a really difficult one, because even I've loved space since I was a child. I loved maths. There was never really any doubt that I was going to become an astronomer. And yet, even when I was choosing subjects in high school, I still doubted whether I was going to be able to do it. Surprisingly, because I wasn't sure if I'd be able to handle maths, even though I'd already signed up to do the highest level of maths. So it's all very paradoxical, and it doesn't make sense. But I think it's a really big issue that a lot of females basically think that they can't do it or they're not good enough. And there's a lot of research that goes into that as well. And it's especially in physics and engineering that women have this imposter syndrome, and they think, I'm not good enough. And at some point someone's going to realize that I don't belong here, and then they're going to kick me out. And I still suffer. I still struggle to overcome it. And it's really difficult. And there's a whole issue of self-efficacy. And I think what's really important is, encourage actually going and seeing things and helping them to tackle questions or triggering that curiosity, because basically if they've got the passion for the subject, no matter how they think they're going, they can push through. Because I love space so much, and yes, there's been a lot against a female in physics, and it's very difficult to overcome the issues associated with that, but I just love it so much that it basically gets to a point where I'm like, I don't care if I'm good or bad, I just want to do it. And I think, I'm so glad you're asking and that you want to encourage her. I think that's basically step one, is a huge check that you are passionate about it and you want to help her out. And I think if you just keep going with that, so take her to museums, take her to as many places as you can, talk to scientists, and backing Kathryn with art is a really great way to go. Just immerse her in as much physics as you can. And whenever she's feeling down, like it's inevitable, and I have those days, everyone has those days, they're just reassuring her that that's just a side effect of physics. That's what happens. But the joys that you get out of it are way better, and they far outweigh the negative. So continue to immerse her and encourage her, because that's really what we need, is the positive reinforcement that females can do it, and everyone can do physics. It's not that hard if you love it. It's great.
I would absolutely agree. And I would just like to say that, you know, the most important thing is really repeating your own self-beliefs to you. Get her to create a vision board. So get her to make a little pin board, get her to cut a picture of herself out in a science lab, because the way that the mind works, the subconscious mind works, is that you need to really visualize, be able to visualize yourself in that situation before you can drive yourself towards your goal. So make it really visual. Make, you know, cut out a little picture of a scientist and pop her head on the top, and then put her in a lab or next to a telescope, and make, you know, and put it somewhere where she can see it every single day, so that it becomes real. And that's the key thing, is that we can actually, every single one of us in the entire chat who've ever watched this live stream, we're going to watch in the future, everybody, you can achieve anything you want to. You just have to have the vision, and you have to remind yourself of it daily. And what happens is, when it's in the front of your mind, throughout the day, what happens is you get these sparks of inspiration. You go, oh, I could do this, you know, oh, I could do that, you know, and they'll just come to you randomly. But the key is to really focus on that every day. So make it a habit, and it is all about habit. But that's it. Yeah. Anyway, guys, we're going to
also just a quick one. When you're putting in your inspiration and people that you inspire,
make sure it's other females as well. Making sure that she can picture herself in those situations, and that she's not the only one. Make it clear that there are female physicists and astronomers out there. So then it doesn't become such a sort of distant idea, because having people that are similar to you is really, really beneficial for you being able to picture yourself in those situations and improve yourself as well. So just a quick one. Now we can wrap up. Sorry.
Look, thank you so much, guys. We've had a great time. And if you want to get in touch with me, I'll be back next week this time. So anyway, sending you lots and lots of love. See you guys.
And, I've got Instagram and Twitter. Get in contact with me with more astronomy questions. Feel free. I'll put my Instagram in the chat.
Great idea. And I'll also send an update after all of this as well, with all of Kathryn's details, if you want to get in touch.
Ask me your astronomy questions, and hopefully I'll be able to answer.
Yay! See ya!
Thanks, guys. Bye.